In this video, we're going to be finding the trig functions of quadrantal angles. And remember, a quadrantal angle is an angle whose terminal side lies on an axis. So we're going to be looking at an angle of 0 degrees, 90 degrees, 180 degrees, and 270. Okay, so the first thing I've done is drawn in a 0 degree angle, and I've labeled a point on the terminal side, XY. Remember that we have defined r as the distance between the origin and the point on the circle. So in this case, my r value is equal to x. You can see here that I've written out the first three trig functions and their circular definitions, and we're just going to fill this in. Now remember that when I'm on the x-axis, my y value is 0, so this is the point x0 that I'm going to be looking at. So y is 0, and r, I'm just going to keep r. 0 divided by r is just 0. X over r, I'm going to say that is x over x, because remember x is equal to r. So x divided by x is 1, and y over x is going to be 0 over x, which is 0. Now for my next three trig functions, I go back to my circular definitions. This would be 1 over 0, and that is undefined. For secant, again, I could use the definition r over x, or I could just take the reciprocal of 1. 1 over 1 is just 1. And cotangent would be x over 0, which is undefined. I'm going to start this problem off similar to the way that I started off my angle of 0 degrees. I've drawn in my angle. I've put a point on the terminal side of my angle, and I've labeled that point xy. The distance between that point and the origin is what we call r, and in this case, that distance r is equal to y. The point xy is actually 0y, since I am on the y-axis. So now I have enough information that I can use my definitions over here and figure out a numerical answer for each of these functions. Remember, r is equal to y, so I have y over y, or you could say r over r. It doesn't really matter either way. That's equal to 1. X is 0, and r, we're just going to keep r. 0 divided by r is 0. And for tangent, we have y over 0, and that is undefined. For the next three trig functions, I'm going to go back to my circular definitions. Cosecant is defined as r over y, and in this case, r and y are equal, so you have r over r or y over y, and that is equal to 1. Secant is r over x, but remember x is 0 in this case, so secant of 90 degrees is undefined. For cotangent, we have x over y, and remember that x is 0, so I have 0 over y, and that is 0. In my next problem, I'm going to be looking at an angle of 180 degrees, so I've already gotten my angle drawn in, a point drawn on the terminal side of the angle. I've got that point labeled as xy, but we can also be more specific in that and say that it is the point x0. Remember that r is the distance between the point and the origin. Now I would like to somehow get this r value related to the x coordinate or the y coordinate like I did on the first two angles. And I think it helps if I looked at this with an example with a number. If you look at this example, I have the point -3, 0. The distance between that point and the origin is going to be 3. So if this were the point -5, 0, that distance would be 5. This distance is always the opposite of this x-coordinate if I am on the negative side of the y-axis. This distance that I'm going to call r is going to be the opposite of my x-coordinate. So the opposite of -3 would be +3. So going back over to my diagram of 180 degrees, my r value is going to be equal to the opposite of x. So again, I've got my circular definitions written down, and I'm going to fill in what I know. Y is 0. R, we're just going to keep r, because anytime you have 0 in your numerator, you're going to have 0 for the answer, unless your denominator is 0. For the next trig function, I've got cosine of 180, so this is going to be x over -x, which is -1. For tangent of 180, my y-coordinate is 0. We're just going to keep x, so 0 over x is 0. And there are your remaining trig functions. Okay, for our last angle, we have 270 degrees. I've drawn that in. I've plotted a point on the terminal side of my angle. That point is xy. In this case, x is 0, so the point is 0y. The distance between that point and the origin is what is defined as r. And in this case, r is going to be equal to the opposite of y. So I have my first 3 trig functions written down and their circular definitions. I'm going to fill in what I know. Sine of 270y over r. I know that r is equal to -y, so I have y over -y, which equals -1. Cosine is going to be 0 over r, which is 0. Tangent is y over 0, which is undefined. And there are next 3 trig functions. We're going to fill in what we know and simplify. And there are our last trig functions. Okay, there's a couple of things I want to mention about the 6 trig functions in relation to the quadrantal angles. First of all, now that we have done this, we have found the 6 trig functions for every angle from 0 to 360. And actually, we could keep expanding that and go on to angles that are more than 360 degrees, right? 390, 720, and on infinitely. Or we could also look at negative angles. So by doing these problems, we have been able to now look at circular definitions for any angle. The next thing I want to mention about the quadrantal angles is that I do these problems a little bit different than the way the book does. I think the book sort of gets ahead of itself in the way they're explaining it, and they really sort of get into what we're going to be talking about with the unit circle in our next section. So I wanted to teach this in a way that's strictly relying on those circular definitions that we did at the beginning of this section. We are going to come back to quadrantal angles later and look at it in a different light, but I do think it's important that you understand how our trigonometry is progressing. We started off with trigonometry in right triangles, and now we're going to move to what we're going to call our circular definitions. And really, we haven't seen circles here, but we will. And that is going to be our next unit of study.